guys ready?
I think so.
Okay, let's go. All right. So, hello, ladies and gentlemen. We are representing our company, Fine Electrics here, and we are doing a presentation about Ghana. Everything you need to know. All right. So Ghana, it's a country in West Africa. It shares a border with Cote d'Ivoire and Togo, and the Gulf of Guinea is to the south. It's on kind of like close to the, it's on the side with the Atlantic Ocean. And it has its own top-level domain, .gh, for when you have to go to Ghanaian websites. Just bear that in mind, you know, government, whatever. All right, so the official language is English. That's convenient. So, you know, it's easy to interact with the locals. But there are 60 indigenous languages in the area as well. There are, the majority of Ghanaians do speak English, though, and signage and government paperwork and whatnot will be in English. So if you're traveling over there, it makes it really easy for you to just kind of navigate and communicate. But there are a lot of ethnic groups in Ghana, and it's something you should be aware of if you're going over there for business or anything. You know, just know kind of that there are different groups like Akan, Dagbon, Iwi. These are the major ones. Almost 80% of the population they constitute. Ghana's primary exports. This might be information you want to know if you are with another company that you know you are interested in the region. They have gold, silver, diamonds, many valuable things, uranium, and of course petroleum and natural gas, which is very valuable. It has a $113 billion GDP, and it continues to grow. A lot of resources in the region. And their currency is the cedi. Ghanaian culture is strongly rooted in tradition, which is something you know you should bear in mind. And respect and etiquette is very important and highly valued in both informal and business environments. And to talk about respect and etiquette, Derek.
I'm going to begin with traditions. Traditions are of ancestors are still a very important part of daily life. Important life events are marked by special rites and ceremonies and rituals. Child naming, marriage, and death are marked by family ceremonies. And seasonal festivals bring people together in celebration. Those pictures are actually from the annual Amoo Festival. These were taken in 2015. It's the people of Teshi. It's a fishing community. It's celebrated to mark the end of famine when their people moved or migrated from Israel to where they are now to present time. Next is culture. Generally, Ghanaians, I think that's pronounced right. Ghanaians are mostly a conservative people. Family is very important in Ghana. It takes precedence over many other things. People are respected because of their age, experience, wealth, and position. Tourists, as a tourist, you're expected to dress decently. They are expected to take off. Tourists are expected to take off shoes when entering sacred ground, not to take pictures without permission. Also, do not enter a home without an invitation. I don't know why you'd be entering a home without an invitation. You'd probably be in trouble anyway, but an invitation is a sign of friendship. When you're meeting new people in Ghana, it's kind of like America. Right-handed handshake, the smile is accepted. There actually is a Ghanaian handshake, which involves a normal handshake, and then it's gripping. I have a picture of it. It's hard to describe. Like gripping the other person's middle finger, something that you slip away. It's strange. They say to avoid it unless you're familiar with it. So just an ordinary handshake. Offering a gift or eating with your left hand is something that should be avoided. If you offer a gift, it should be with your right hand or both hands. Gifts are better as thoughtful things more than expensive side of wealth. And always address Ghanaians by their academic, professional, or honorific title. So, respect. Dining etiquette. Use formal table manners. Wait to be told of seating arrangement. It's interesting that generally food is served in a communal bowl, so it's not like you're at all, but a washing bin is used to clean your hands before eating, and like I said, food is sometimes served in a communal bowl. Do not begin eating until the eldest male does, as a sign of respect. Never reach across the bowl, just eat what's in front of you, and never use your left hand to eat. And if you don't actually want to eat, you could actually ask for utensils. And to talk about business is qua.
Alright, so variables that are important in Ghana's business etiquette are time flexibility, familiarity, hierarchy, professional and academic ties, and reputation. So first up is time flexibility, concept of time. So concept of time refers to how, like, a margin of time before and after a business meeting. That's more important than being punctual, because you can't account for all variables, so sometimes a meeting will run late or will start late, so that's important. And then there's familiarity. It refers to the aspect of getting to know your business partners. Usually they start the first meeting with just conversations about family, health, social life. It's just to get to know each other, and they try to determine if they want to do business with them in future. And then once that is done and they figure out if they have a harmonious relationship, they'll get into the business. Another important thing in business etiquette is hierarchy and social status. So this refers to addressing people respectfully. Before you enter a business meeting, the person that takes you there, you should ask them how to address everybody else in the meeting, because you want to address people with their appropriate titles, whether it be professional titles or academic titles. Reputation is important in Ghana because just face. So loss of face will not only affect them but their family as well. So it goes farther than just themselves. So if one's like counterpart can lose face, they try not to fill the silence. So they just try to ignore it and let it pass. Indirect communication is big in Ghana. So yeah, they don't want to put anybody in uncomfortable situations. Yeah. That's good.
It's the end of our presentation.
There's a signal that time's up, by the way.
So I was right on time.
Well, a little over, but
It's close enough, round it down.
Okay.
thank you, folks, for your. I'm just. What made you select this country? Has anybody been there? Anybody have roots?
Quad boarded it out with me, sorry.
That was just
I'm gonna go there eventually.
on your road
We
trip.
were all
Yeah.
John Jerome, welcome. Thank you for coming. I just would like to explain, since you're a visitor, what you just saw, because this is the project's presentation, and clearly they're talking about a foreign country. So one part of the requirements for the course is the students get work in teams and they have to research another culture with the idea that their company, their electronics business, is either going to be selling their new products in a foreign country or they're going to be doing manufacturing in a foreign country, which is very common these days. I mean, we are in a global economy. So each group will present on their choice country, okay, and then they'll move on to their individual. So Derek is going first.
Lots of face, good.
Okay, she's in.
Well,
You can do that. After Derek's special.
yeah, I want to be special.
Right after Derek. For Brazil. And then we're sending. And then another country. Countries first, and then private. After Derek's special, it's 7 visits.
But I'm special.
Yeah,
Oh, dude, what is it?
exactly. That's why you're special, because you're the only one that volunteers.
Oh, is that insult?
No.
It's hard not
I
to
would
insult
never
you.
insult you,
Is it
Derek.
flash drive still on the computer? Okay.
I think so, there's 3 in there.
I wonder if we have is there a remote control up there?
Jeff?
I'm wondering is, because, you know, you stand in the middle, which is the most comfortable. Just if you could all try, 'cause what I'm noticing is the lighting, that makes half your face dark and the other half light. You feel it in your eyes, right? The sun
Yeah.
is shining through you. It would just be nice if we could stand kind of out of that
Yeah.
spot like that.
He's such a bright young man, that's why he's got those lights.
Yeah, well, the sun is shining bright today. Let me know, I'm ready whenever you are, so.
What if I just stood up here? So I did, should I start now?
Yeah.
I did an ESR meter. The first question to be answered about my project is, what is ESR? ESR stands for Equivalent Series Resistance. It is the resistance of the leads and losses in the dielectric. It's basically the total resistance in a capacitor. It exists in non-ideal real-world components. It's dynamic, so it's not a static thing. You can't, as we know, you can't connect a capacitor on a DC, like DC meter. It'll just act as a short, and you won't be able to measure anything on it. It exists with a fluctuating or alternating current when an alternating current is applied. This sounds a lot like reactance, so it's actually different than reactance. That's my next slide, is how it differs from reactance. Reactance has a real and an imaginary component to it. We know that from Eli and Iceman, that current leads voltage in the capacitor. The actual ESR is the in-phase AC resistance. So it's the actual total resistance. It's confusing. Like, researching this, I gotten so in depth with it that I actually see how they develop capacitors and all the different formulas. There's tons of different losses, but this is considered, ESR is considered the total resistance. So in order to measure this ESR, you have to remove the reactance as much as you can. Because the total AC resistance, if that's given as V sub C, then you would want to make this portion of it as close to 0 as possible to make the ESR the total resistance that you're measuring. So how to do this You need to generate at least 100 kilohertz. That would make that, the previous slide, make this part, up here, a higher number down here. So you'll have a smaller, closer to 0 number, which will make that the resistance closer to DSR. You need to apply this signal to the capacitor and create measurable results from that. So in order to generate the plus 100K frequency in my circuit uses a 555 timer as an astable multi-vibrator at certain values to make a 146.2 kilohertz frequency. So this is my full schematic. This is the 555 timer up here. Initially to start, I have a low dropout regulator. This regulates a 9 volt input to 5 volts. So I have 5 volts supplied to this 555. That then sends a signal through a transformer, an isolating transformer, which separates any impedance that's introduced from the 555 from the rest of the circuit, because it could be quite sensitive to changes in measuring the capacitor. And we'll go from there. The test portion has input protection diodes, and these 2 resistors are for input protection. So for smaller value capacitors, if they're charged, it will safely discharge through these resistors. So you could actually put in charged capacitors. It's then coupled to a BJT, common emitter amplifier. This is to separate the voltage that's feeding the amplifier from the AC portion. And then coupled to a half-wave rectifier, which removes the negative portion of the signal, filtered and sent to an output to be displayed, have the voltage displayed on the output. I also sorry. I'll figure it out. So the idea behind this is that this test 100 kilohertz signal is sent to the capacitor. Oh, it's first dropped down. This is a 2-to-1 transformer. So it drops it down to a safe level where it will not forward bias any PN junctions. So the capacitor can be tested in circuit without risking damaging any components. So this smaller signal is then amplified to a readable voltage here. The idea is to set this with the potentiometer to a specific reference voltage, and then when you enter a capacitor into there, it'll measure the resistance of that and display a drop on the voltage, the reference voltage. So I first breadboarded and I tested the voltage regulator output for 5 volts. I initially put in the transistor backwards, so that was a pain in the neck to figure out. But I got that running, and then I verified on my 555 output that the frequency was roughly 100K. It actually came out to be exactly 100K because of losses. And that was interesting, but so that was operating correctly. I was able to get 3 volts on the output to be able to test capacitors, or have enough room to test capacitors. Supposed to delete that. This is the PCB that I got manufactured. I didn't have any actual pictures before I started soldering anything, so this has resistors in it. This is a fully populated board with cables. It's the back of the socket. When I finished soldering the board and I tested it, I had errors. I was not getting an output. I later found out, after lots of trying to figure it out, that 2 diodes were put in backwards. So I fixed that, and then everything worked fine. For testing, I tested 2 different portions of it. This was at where you input the capacitor. I tested the waveform there and the waveform on the output up here to make sure that the amplifier was working properly. And that came up with 400 millivolts at that first point and about 4.5 volts at the first. The amplifier is supposed to have a gain of about 10, and by applying V out over V in, I got around 10, so it's operating correctly. Next is how I made the enclosure. I actually cut out a piece of plexiglass, measured it, and all the front panel parts for it, so you could actually see through the entire enclosure. Assembling the enclosure. You go through all the steps. And this is the completed project. I actually made a quick reference chart on the front to help you determine if the capacitor is good or bad. Testing this. I couldn't really get a bad capacitor to test the resistance of it. So I attempted to destroy a capacitor to get it to work. This did not work that well. The first one that I tested tried to heat up to evaporate the electrolyte inside, actually blew up. The other one just caught on fire before the electrolyte. This was the fun portion of the project.
I'm glad you weren't doing this at school. I see a stone wall. That's not
Yeah, no,
here.
this is at
And the
home.
safety glasses, that's key, right?
It's kind of like, yeah, it was safe. I was kind of leaning away when I did it, so it didn't blow up in my face. I found the most effective way to destroy an electrolytic capacitor is to connect it in reverse polarity and then slowly increase the voltage until the magic smoke comes out. So by doing that, I got 2 bad capacitors that I could show exactly how the meter works. And that brings me to operation. I don't know if I could bring it over here
Maybe-
to show.
How about, let's use the document camera. I'll calculate this. Will it reach your battery so you can look at it? So also we could do.
No, it's difficult to explain exactly how it operates because for me, I've been working with it for like a while now, but it's
Just, you know, throw it up here just to see if you
step by step.
Hey,
Easier
just
to
explain what you're
explain.
doing, we can see it.
Okay, so first I short out the cables. If you can see it, I short it out and set the reference voltage. So the reference voltage is set to 3 volts. When I connect, I now disconnect them. And when I connect in a capacitor, to test a capacitor, right now I have a good and bad. Oh, did I fall off? Right now I have a good and bad of like the same value capacitor. A good capacitor will have like almost no ESR of like the same value capacitor. A good capacitor will have like almost no ESR. There'll be no resistance added to the circuit. So this is a good capacitor. It's still exactly 3 volts. There's no loss in because of resistance. Okay, disconnect that. Put a known bad capacitor in.
resistance will cause a very significant drop in output voltage. So I have a table on here, and it's actually much higher than 10 ohms. So this capacitor is completely shot. It'll cause all kinds of failures in the circuit, overheating, all kinds of bad stuff. And actually down here, there's a chart where it has capacitor values at a certain rated voltage and what the ESR should be. It's a very general guide, but basically if you have any significant amount of resistance in a capacitor, it's going to be bad. It's bad, but very bad for the circuit. I have another set of capacitors, but I think that pretty much illustrates what it does. Any questions? 'Cause I know I missed a lot of stuff, but grazed over a lot.
So what was your what was the factor in picking this kind of
Well,
project?
I mean, I've seen videos of people online where they pick up like a TV from the garbage or something like that someone just threw out, and they don't know that like the only thing wrong with it is a capacitor. Electrolytic capacitor dried up. So you pull
How
out
do
the
you
old
test
one,
that?
and a new one, and you got a free TV. So it's pretty interesting. I mean, a lot of old circuits and stuff use electrolytics that had bad ESR. Like now they've developed low ESR capacitors, but it helps in repair of old equipment.
Yeah,
So
absolutely.
it's useful. It will come in handy. We'll use it.
Good. Seems to work very well too. Any other questions for Derek?
What was the most complicated part of this project?
Probably the whole thing. I mean, most complicated part was figuring out how everything worked. I mean, I'm sure we all familiar with that. Like actually taking apart the circuit, and then all the stuff, all the parts of it. Right? Answer?
Yeah.
If you had to do this again, what would you do differently?
I don't know, I'm happy with what I came up with.
Yeah.
I mean, I'm happy with this. I wanted an ESR meter. I didn't want to pay as much for this. I probably could have got a better deal, but yeah, it's useful. I'm going to use it, so yeah, I like what it is.
All right.
Very good. All right. Thank you.
I just kind of assumed, are you going?
No, absolutely not.
Oh.
You look so
No,
proud when you
you're-
brought up Eli the Iceman before.
Oh, I love that. Yeah, right? You heard the Eli the Iceman, John? Yeah. John here is in circuits
it
2
now.
right now. So yeah, in the impedance equations, yeah, we've been looking at those recently. Also, Scott is going next. Yeah, you were good. There were some questions. I had, what was it? It was like 13 and then there was questions. So I think I would have the 2. And then when you up there with the document. It's why you need to, yeah, if you practice, you get a better idea of the time. But yeah. Scott, you're doing PowerPoint, right? So, yes?
Not to overcomplicate things even more, but this big lip ain't gonna fit in there.
It won't fit in there. There's what you're gonna do.
Alright.
I need to get one in.
Yeah, I know. I'm sure one comes worse.
Something down there.
Can I come too? Or is it just
Exactly what it is.
No, all that is like-
The columns to dry out the floor.
I put 3 of them.
Yeah, that's what I thought.
Easier to get to, and then this.
want to go with
No, I'm gonna say. So this is actually a little something.
What did that do?
And then the rest is like just this, which I'm changing it. Like this one's mine, It was just for the year. And for like the end of it, and just when you have kind of like, host business college usually tends to end meeting and like just working with, just bringing them to the tourist spot, and this is how I'm ending it because it ends with the tourist spot this year.
Oh, I didn't.
We out.
I went up to me on that one.
So,
Go big or go home.
Preferably go home.
Yeah, before I was alright, we go. Now we
Yeah.
What is that, reverse? Is that reverse?
One of the outlets here.
Oh, that sucks, but okay. Make it.
Well, that's just for your demonstration.
Yeah.
So,
Yeah, we will. Never say that.
Scott, or maybe over here would be, I'm just trying to put for the visual to not be stuck in the corner over there. Well, we'll see. Maybe, well, that's at the end, right? You're gonna get the demo at the end?
Yours was good, like you actually had stuff about the Mine
When he does his demonstration, he's gonna have to move because of the power requirements. Would you be able to adjust the filming?
Yeah, we got the camera that way too, so.
He's gonna have to be, yeah, like over on the side.
Yeah, let me,
But that'll be at the end, towards the end of his presentation.
there we go, yeah.
You ever get it?
Oh, yeah, mission, Let me get that open too, because my schematic is obviously a bit too big to fit inside of a PowerPoint, so that'll be there for when I get to that. Folder.
You know, we're probably gonna edit that anyway, so.
Messed up some formatting. It did. Yeah. We'll make it. All right. So that's not supposed to look like that. Must be something with the resolution, but hopefully it doesn't affect anything else. So.
What's the matter?
I don't know. I did this on higher. I made it on a higher resolution monitor than this, so
Okay.
I don't know. I could try to set it down. But I don't know.
Well, don't worry about it. I think it looks okay.
It might affect other
Oh, that might be
things,
hard to
but I don't know. Okay, we'll find out when I go through it. So let's start. All right. So I'm Scott. You know what I'm saying. And I made a audio spectrum analyzer. So we'll get started here. So my design goals were to create basically just a 10-band audio spectrum analyzer. And how I went about this is I started with the idea of like a VU meter. So it's basically just a voltmeter for and to make it a spectrum analyzer, really a spectrum analyzer is just a bunch of different VU meters that look at different frequency bands. So what you need to do is you need to do some filtering. Bandpass filtering is the filtering I used. So you need to determine the type of filters, the component values. You want to use passive or active filters, etc. Peak detecting. How do you want to peak detect? Do you want to use like a simple diode? Do you want to use more active peak detectors? So you have to look into that. And then the implementation of kind of how you're going to drive the LEDs. I have an LED driver chip. At first I was planning to use several, then I decided to do some kind of multiplexing. So the process was to kind of go through and figure out everything I need. So I have a simple block diagram here. You start with an audio source, whether it be an iPod, an iPhone, a computer, whatnot. And because I don't want to double the amount of circuitry I already have, I use a active mixer to mix the left and right stereo channels to mono. Then I put it through, at first this was just an input buffer, but then I changed it to an amplifier because it turned out there were losses in the circuitry that necessitated that I amplify this. I played around with the gain a little bit. I did a gain of 5, I did a gain of 10. Ultimately I settled on the gain of 15. And from this amplifier, you go into the array of filters. I have 10 of them. Each one is at a different has a different center frequency, and they're spaced 1 octave apart. From the filters, we got to make that not do that. It goes into the peak detectors. Oh, those are still with filter. Okay, that's supposed to be peak detectors. And from there, they get multiplexed. They go to the LED driver, and from there they go to the LEDs, and there's some switching circuitry up there to drive this. So let's get a little more in depth. So this is a schematic. I was having some trouble in the design phase at some point, and a helpful, it's actually somebody, an Estonian posted this on an image board. Really helped me out a lot. This is kind of what's going on. This is very similar to what my filter array looks like. This isn't exactly what I have. He's got the switches right here. He used a CD4016 for the switches. It's a quad switch. I ended up using one of those in the end. He's got a Johnson counter up top, and this is basically it's like a flash ADC. You got our comparators, you have a resistive ladder divider, the IC I used for the LED driver has effectively that circuitry inside of it already. Whoops. So actually I will go and get into here because like I said, my schematic is far too big to fit on a PowerPoint slide. And it might be far too big to fit on here too, but I'll do my best. Oh, okay. All right, so we have, this is our mixer right here. It's an active mixer. I will say that all the op amps in this circuit are single supply. This is the amplifier right here, non-inverting. We have all of the filters right here, multiple feedback bandpass filters. Basically, they're configured so you have a differentiator and an integrator. That basically combines a high pass and a low pass to create a bandpass filter. The name multiple feedback obviously comes from 2 feedback loops, one right here, one right here. Easy. From there, we go to the peak detectors, which are right here. They're all the same. literally no difference. Basic, simple, active half-wave precision rectifier. And then they go through a connector over to my second board. And it's on this board where the magic happens. Okay. Go out into the signals go into the inputs of these switches here. They're driven by this control circuitry down here. This is a 555 timer, generates a 2 kilohertz square wave. Goes into here, controls this Johnson counter. Johnson counter, one unique output state at any given time. So it's just going to cycle through these, and that will put a high on the control lines of these data select switches, and it will also put a high on the, put 12 volts on the base of those transistors, which are connected to VCC, which will allow current, allow current to flow into the anodes, and that will allow each LED bar to light up. So the signal will be matched with the corresponding LED bar. And it cycles through this so fast, like 2 kilohertz, so you're not going to be able, they're all going to look like they're on at the same time. The real advantage of this compared to my original design is it saves a lot of power. Because I was originally going to use 10 LED drivers, and they consume a lot. I would have been pulling close to probably like 2 amps of current, and I'm pulling, when like all the bars are almost lit to their max, I'm pulling maybe 200 milliamps, usually less. So it does save a lot. So let's get back into it. Like I said, multiple feedback bandpass filters, pretty low quality factor, usually between 2 and 4, depending on which filter range you're looking at. And I got 10 ranges, 31 hertz, 63, 125, 250, 500, 1K, 2K, 4K, 8K, 16K. And I found this nice table on a website called Elliott Sound Productions, which really helped me with the filter design, because I was originally doing this on my own, trying to calculate it, and it's not impossible to do, but it's a bit of a pain. So it's nice to, when the work is kind of done for you. The peak detectors, the halfway peak detector I got came from the LM3915 data sheet. They had some suggestions for peak detectors, and I used the halfway peak detector. I made some changes though. I used a TLC 2272 instead of an LF351, and I have a 100K bleeder resistor in here to discharge staff capacitor that holds the peak value, so it'll only hold it for a certain amount of time, not too long. The digital switching, like I said, CD4016 were the switches that effectively multiplex the 10 channels. The Johnson counter has the decoded outputs that control the which switch is selected and which LED bar is selected. And the 555 timer, 2 kilohertz, 50% duty cycle. And the LED driver, this is a block diagram from Texas Instruments of what's going on inside. Very similar to that other thing I showed you, resistive ladder, the comparator, when it drives, the signal comes through and this goes low, then current's going to flow through. It's got an input buffer, and it has a mode select switch, which I'll show you later. Spoilers. So this is breadboarding, the early stages. I only have like 1 LED bar. All my filters, the filters really didn't change through the stages of breadboarding. This part was pretty good. I was using 2 DG406 16-channel analog mux demuxes to start, and those really weren't kind of working out. I was having some issues with the switching and timing, charge injection, weird things like that. Here it is, still early on the breadboarding, a little later. I got my logic analyzer out and probing just to make sure that, I had a decade counter at that time that was, just make sure it was doing the right count sequence, and it was. So problems weren't there. This is a little later on. I got more LED bars hooked up. At this point, I got rid of those 16-channel analog muxes, didn't want them. Got CD 4016, 4017, it's working a lot better. I still had a couple issues at this point, but a lot of it was due to like bad wiring and whatnot. Later stages of breadboarding, very similar, same kind of thing. Got audio in, output peak detected, and you know, it was working pretty good. It took a long time to get there. And then of course we get to the PCB design. This took forever. This is the board with all the filters on it. The filters were up top, these 3 ICs up here, and the peak detectors are the 5 down here. So 2, 4, 6, 8, 10, and then all the rest. There are a couple issues with this, most notably thermal relief errors that took a little while to figure out, but eventually we got there. That was because of this big ground plane that I have in there. I can, jeez. I don't actually have the pictures. I have them somewhere. We'll just go through it like this. That is the, well, this is the filter board with the filters up here and the peak detectors up here, unsoldered. The back. Oops, these are not in any particular order. This is the LED board. Here are the LED bars where they'll all go, the LED driver, the CD 4016, the switches, I think the 4017 is up there somewhere. 555 timer up in the corner hanging out. We got these transistors. As they're so small. But get through it. So there's the back of that unsoldered, of course. And there's some work done on that. And here's the front before I put those capacitors in. Well, I got one of them. So, you know, I use like 2.2 mic for bypassing and stuff like that, 470 mic for supply bypassing. The back, I put the LED bars on the back. There were a couple issues putting them on the front. And it just wasn't working out. I think what ended up happening was I had wired stuff, I'd mixed up like the cathode and the anode or something. So I had them wired wrong, and basically they were going to kind of light the wrong way. And because they were multicolored LED bars, you know, typical convention would be for like a spectrum analyzer for audio to be like green, yellow, red, with red being your overdriven. It would have lit up the opposite way. So I put them on the back to resolve that. Because I could put them flush against the case when I did that, because I couldn't do it before because that big 470 mic cap was sticking way up. So, you know, it was kind of better that way, so I said, It created a couple of small issues, but nothing too major. So, there's the fully soldered board right there, and I should have the fully soldered this one. That took a while to do. But it wasn't as bad as you might think. And here's a picture of it working at some point when I was fiddling around with it. Hopefully it still does that today. So we'll get back into it here. Go through all that. Okay. And there were, I made a lot of mistakes along the way, but hey, that's how you learn, right? A lot of miswiring. A lot of the issues I had with my original design, I think, were due to miswiring. Issues with timing. You know, I originally multiplexed through one peak detector, and there were issues with that and the RC time constant I had on the you know, the peak hold. What are you going to do, you know? Failed to take charge injection into account on the DG406. That was introduced as errors. The missing thermal reliefs, and of course the infamous annular ring error that we didn't know how to resolve for ages. Seems silly now, but you know, when you're in the cars of it, man. Can it be improved? Well, yes, it can. The easiest improvement would be to do this with a microcontroller, additional signal processing, and cut away like all of this. You know, you could like get rid of one of these boards entirely and probably make the other less than half the size, you know. But I haven't taken microcontrollers till this year. I don't know a lot about coding micro, so you know, that would have probably been more work than this, believe it or not. So really wasn't realistic for me. And as far as improving the analog design, yeah, it could probably be improved. You know, the inputs to the filter should really be input buffered to keep the impedance low. And, you know, you could, better peak detectors, more accurate resistors, or, you know, or just dozen and one different things you can do to make this better. But I think what I got is pretty good, all things considered, especially with time constraints. So, with that said, let's show it off. I have to find a place to put this in. I should say there's no on off, so it should probably immediately when you connect. No? Oh, okay. And I will also say that this case, I don't have a lot of pictures of designing it, mostly because I kind of winged it. It's full of holes from connections that I did wrong, so, you know, it's like Swiss cheese. Oh yeah, I need to, I'm gonna do that. How close can we get that connector to overkill, the audio one?
Probably not very. Yeah,
Okay, I might be able to.
oh, wait, hold on. If we, can you use this one? There's some play, listen. Well,
Yeah, if I can. Well, yeah, I could probably just do this on a chair or something. Perfect. Okay. Hey, there we go.
Here's something.
All right, so let's play some music, hopefully. You can see it works. These pots right here, this adjusts the reference voltage. Basically, you use this if you're putting in like an amplified signal, you know, because if you amplify the signal by like 10, 15, 50 times or whatever, all these bars are going to be at the maximum. So this kind of just lets you calibrate it to, you know, whatever your input voltage, I guess, is. And this is a brightness control. You can dim this or brighten it. And this button changes modes between dot and bar mode. So here is just like a scanning dot mode. You see that?
Any chance you can hold it up? It's just a little hard. Yeah. Okay. Yeah. Now we can see.
So stop and bar mode, and that's basically it. A lot of work to do something like that, but I like it. I think it looks cool. And I got another song. I like this one because it really shows you kind of that the filters are working, because you can see it's got like an arpeggio. It's like da 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 da. It's the opening to the Final Fantasy of any of your RPG players. So you can see lower frequency, higher frequency, lower so you can see it shift. Just to show you it's not just doing nothing, you know? It is actually filtering and it is actually peak detecting and it's working as intended. So, a lot of work, but I'm pretty happy with it, all things considered. Glad I got it working.
Worked out well.
So that's it, I guess. Any questions?
What would you do differently going back?
A lot of stuff probably, you know. Honestly, if I had more time and stuff, I would probably try to do this digitally instead of analog. I mean, I really like doing it the analog way. It's really cool. I learned a ton of stuff. But the easier way would be DSP all the way.
Well, it was quite an undertaking, and I'm glad you pulled it off in the end, and it works great. So congratulations!
About coming in without a project to come to fruition.
Excellent. Any other questions? Thank you very much, Scott.
Unbreak them on there.
Claude, you can start preparing while he's disassembling.
No rush though.
Don't worry, I'll fix it for you.
No, I think I wouldn't even know where to begin.
Oh, this is website. But it's coming. Website's Microsoft.
Apple. There, yes.
What did I miss? Did I miss anything?
And Scott was the second one.
Was it awesome? Were you awesome? What was your project here?
It's an ESR meter.
You know, I'm a psychology major.
Just assume,
I just
like, just pretend you never know what you're talking
It
about.
takes a lot of explanation, but it's like, it measures pretty much the resistance in the capacitor.
Okay.
So,
And you created the whole thing?
no, I got the schematic online.
You did.
I didn't actually talk about what I modified with it. I did a few modifications, but mostly, yeah, it's circuit.
So what are you doing now? Are you going on to school or?
Well, I'm planning, I actually have an interview tomorrow for Neeltran.
So you're going out to work?
Yeah, hopefully.
I would make one up and bring it up.
Bring what you know what, the other thing is.
That's what works for me.
Bring things that you've done. Like when I've interviewed people who are hired here, like when they bring you things.
Oh, that's what I just did.
Yeah, it gives you something to talk about, when you're there and, shows that you have. So just just me and you talking.
Maybe I'll ask her if I could leave my button. She's interviews tomorrow.
Making a whole bunch of.
Yeah, I think a whole other one. After like 1 hour of sleep last night.
Get some rest tonight.
Yeah.
But isn't that how it always is, though? I mean, our fields are kind of the same. You guys get limited sleep, we get limited sleep, so it's all in the same.
Yeah. Well, that's.
So you guys are all graduating. That's exciting. Not yet?
December.
December.
Yeah, not yet either.
You're going to, I think she told me you're going to electric boat.
Yes.
That's awesome. Did you get the job already?
I have a job. I'm just waiting on my DOD background check,
Excellent.
which is taking forever.
It does take.
It's 4 weeks today.
I have a nephew who was down there as an intern, and they want to hire him, and he's been there for 4 months or so, and his checks aren't done. Because the level of clearance that they need for whatever it is he's doing now.
Yeah.
So don't get discouraged.
Oh, no, I already have my employee number and
Oh, good.
everything, so I'm all
Good.
set.
That's awesome.
I'm just waiting on go time.
Yeah.
That's it.
Where are you working?
General Dynamics electric boat.
Oh, okay.
Do you live down that way?
I live in West Haven.
Oh, that's not that bad then.
I'll be an electrical design structural draftsman.
Nice.
That's awesome.
So, my project was a voice recorder. And I did it very simply with just two of the primary functions, which are to record sound and to play it back. This is the initial schematic that I started out with. It revolves around the ISD 2560 IC. And a lot of the filtering and amplification occurs inside the chip. So basically all I have are inputs and outputs and more filtering. So how it works is that I have it set up in push button control mode. So that's why the start and stop buttons control the voice recorder. Start to record a playback and stop to stop either function. The chip enable is an active low, so I used a pull-up resistor to have a low signal go into the chip enable when the start button is pressed down. And that will either record or play back the sound. And the stop button is pulled down because it is connected to the power down pin, which is active high. So send a high level when the stop button is pressed, which stops the functions. And I'll also reset the address to 0. To select the modes of operation, I have a single pull double toggle switch. When it's pulled low, it is in record mode because it's active low, and then when it's pulled high, it's in playback. There's filtering on the microphone, and then also changed my speaker from 16 ohms to 8 ohms because I had a volume adjustment circuit. I also added a voltage regulator to have this have voltage applied from a battery. And yeah. So for this circuit to be in push button control mode, these two pins are the most significant address bits. They're pulled high, along with, can't really see it, but this is M6, which refers to mode 6, which is the push button control mode. So that's the only mode that's connected. It's compatible with a few others, but I didn't use those features because some of them require a microcontroller, and yeah, so. So when the chip enable gets a low pulse, there's some delay from just power. And so when I go to demonstrate later, there will be a slight pause after I push the button just to get through that delay. I have this set up to record one message with a maximum length of 60 seconds. Although you can pause a recording or play back and then start over again, it's not efficient in that there will always be this added delay, so it'll always cut off some of the playback or recording. And then same thing for playback mode, but low. So this is what's inside this box. Just mainly capacitors and resistors. I have 9 headers, so wires are all over the place. potentiometer for volume adjustment. The only two errors that I really had with this were voltage regulator and I was missing a ground. So with the voltage regulator, my footprints didn't match up with the component. So my second pin on the voltage regulator is ground, but on the footprint, pin 3 was ground, so I had to flip pin 3. So that got, that would have gotten 5 volts out from the 9-volt battery, but I was missing a ground, so without that ground, I was outputting 6 volts, which is way too high, because I only need 5. And so I jumped the wire and got that going. So I made these wires kind of long so I don't have to put my face into the box when I record. So, record mode. So, on the box, top, when the switch is flipped up, it's in playback. When it's flipped down, it's in record mode. The black button is my start button. The red button is my stop. Potentiometer, volume adjustment, power switch, and LED is to indicate when it's operating in either playback or record. So I'm in record mode. Macaroni and cheese. What was that? Put it into playback mode. Oh, and also reset it to go back to address 0, so it plays back on the beginning of the message. Yeah. So, yeah, that's what it does. If I didn't wait for that little bit in the beginning, it would have came out really distorted. So, that's all.
Any questions? What would you do to improve? I'll take Jeff's question because I like his question. If you had more like another semester, you can continue working on your project. Any enhancements you would like to make or modifications?
One of the first things I'd probably do is figure out how to debug it. Like, we tried figuring that out, but the issue was that I was using a Schmidt trigger, and that was inverting the output, and the chip enable was inverted as well. So it didn't go well. It did reduce the noise, but the problem was because it was, when I turned it on, it would automatically run because the levels didn't match up. But we just noise, but I couldn't control it. And then when I tried controlling it by adding an inverter, it added a longer delay instead of 2 or 3 seconds. So I decided to leave that up. Yeah.
Why macaroni and cheese?
I don't know, this is something that I'm craving.
Now I want it for lunch, thank you.
All right. Any other questions? Okay. Thank you. Okay, next group. Who's got a volunteer group to go?
Yeah.
Okay, so this is group of 2 or 3?
Oh, sorry. Here, we'll go, you go do that.
I need your,
Unless you don't want to go.
folks, I need your files copied into the folder that's open right now.
Okay.
Okay, if you can get your group presentation and your individual presentation. Put in there.
You made it pretty simple.
So who do we have? Patrick, Jeff, you're in this group. Who else is in this group? Eduardo, you're in there?
I try not to think about it. Upper back, at least. I bought a lot of extra components too, and it was good because I needed it.
Eduardo.
Factor in the cost of the boards that they still didn't charge me for. I got the invoice, yeah.
Call them up.
No.
No, I did not. Alright, it'll they say got 50 folders missing boards.
It's not fair, I want a refund too. I did get the invoice mailed to me though, and it said they refunded one of the $86 shipping charges, and so it'll cost a total of $152.49 if I remember correctly. If I ever get that. I don't know. Check my bank account. See if the money is gone, but I'll know I can't buy lunch for that. Holy crap.
What's your project? Do you mind if I take this out? Just do it. No, you lift it. I don't want to break it. I just want to,
Okay.
I think it was short.
Yep, they charged me, all right.
Is this, are we, business educator or personal? Business educator? I'm with, I'm like,
I'm going to follow you. See your bill? You just getting it now?
Yep. And they overdrafted my account. I'm at negative $81.46.
That help or not?
only if you go back and forth like that. Perfect.
So who I got?
They overdrafted. They weren't that.
Easier for you next year. When you're in project class, you'll.
This is my personal one.
Bennett's gonna be very mad at me tomorrow. I don't even think the paycheck I'm getting is gonna cover it all.
The bathroom. She was in the bathroom.
That's far.
No, Thursday I'll do one.
So it doesn't like, yeah.
Lord, guess I'm not doing wrong shit. Just fill up on the other ones.
That's why we're here, right? For your job and that's what it's all about. Which one is yours?
It should, that one right there, I think.
With that.
Look at this guy, you're amazing.
I think, I don't know.
Hire him
There's a
again.
whole assistant here now too.
So when I'm
Thursday, I'll be here from like 12:30 till from like 9:30 at night, so. You here on Thursday also?
Yeah, the classroom.
Yeah, I'm trying to look, it's not starting until like 7, so. Leave it in my mailbox, or if you see it, give it to me. If not, leave it in my mailbox. If it doesn't fit, put it on top of the mailbox. Put a note in my mailbox saying, my notebook folks under.
How you doing?
So I know.
Yeah, that's.
Yeah, that's what John did.
That's what I was saying, that's what I was talking about
Yeah,
earlier,
John
like
did.
we should bring it.
Yeah, bring that, bring that.
So it's tomorrow. Oh, and let me know how it goes, please. I already put a good word in for you, I told you. I emailed them.
And the bumpy by
That's your interview at Neeltran tomorrow?
Good job.
And Neeltran's one of the companies that came to present for us.
Nice,
Good job.
that's great.
Yeah, how did we get here? Who else was looking for that? Are you seriously looking though? Have you applied to anywhere yet?
No, because I've had my hands tied up with this, but as soon as I'm done with all my finals.
CS Communications, they looking for resumes, that, I'm not sure match for you. What systems testing?
They're the one that come in, they did the stuff with the airplanes, right?
Yeah.
Awesome.
Mhm.
Simulations. Yeah, that's what I'm looking at.
That's true. When do you get some done?
All right, let's get the ball rolling here, folks.
Okay, we are Peg, Patrick, Eduarda, and Jeff. We are going to do business in Brazil. So, we figure since we are a business going to Brazil, we're going to skip the main, like imports, exports, all that. We're going to stick to our business. The greeting, when you go in, it's very similar to American. You go into a business meeting, you want to have a firm grip, look them in the eye. It's a confident handshake. You don't want to hold too long, but you want to let them know that you're there. And kissing on the cheek, hugs, even though that's common there, you want to avoid that unless you're familiar with the person. You want to be punctual. Being late in Brazil is a huge no-no. They're very not okay with that. If something happens, you run into traffic or whatever, you're going to call ahead. You're going to let them know that you're going to be late. When a group of people enters the room, or when an individual enters the room, the men generally stand out of respect. The women only stand for the host or the superior or elderly, which I thought was kind of interesting. Clothing. The first meeting is formal, and then the executives generally wear a three-piece suit. The workers wear a two-piece suit. I don't have a suit at all, but I'm a worker. I heard the technical fields, the engineers, they are the cool kids, and they can pretty much wear whatever they want, which is exciting for me, because that's my field. You want to avoid flag colors, the yellows, the blues, the greens. It's just kind of a no-no over there. Law and finance, they're always gonna dress to impress. They're always gonna be in suits and ties. Administration starts with formal wear and becomes less formal the more meetings you have. Polo, dress shirts, pants, khakis, etc. for administration.
This is me. So I did kind of like what you would do inside of a meeting. So he did greeting, I'm doing when you get there. So to schedule a meeting, you should schedule 2 to 3 weeks in advance. But with short notice, you're always able to schedule meetings too. To confirm it, you should always confirm it by email. And last minute changes are common because Brazilians tend to change their mind a bit. So it's not anything rude if they cancel on you or if you have to cancel because it's completely common there. To kind of change what Jeff said, even though you have to be punctual, that's mostly in the capital, São Paulo or Brasilia. But in Rio, where I'm from, people tend to be more lax, and to be a couple minutes late is very acceptable. My mom said a few minutes late is more like a half hour late, so I don't know how accurate she is on that. So how to know how to behave before you get into the meeting. Coffee and water is always served throughout the meeting. You do not have to accept it. Brazilians drink coffee throughout the whole entire day, but you will not be considered rude if you do not accept it. Meetings are rather informal, and by that I mean if you're talking, somebody will interrupt you. And it's not because they're rude, it's just how they are. And it's not that they're trying to break down your confidence or make you feel bad, it's just the way they are. Avoid confrontations. We have big egos, so don't crush it, and they're more of a group, like a group kind of people. So if you embarrass them or start a conversation confrontation or criticize them in front of a group of people, like Qua said about Ghana, they're gonna lose face, which is just kind of lose respect for you. So when the meeting starts, there's actually, the meeting starts, but it doesn't start. There's a 30-minute, like, kind of interval we like to start. So you talk about anything but the meeting. Mostly what they talk about is sports, mostly soccer, of course, big shocker. But you can talk about the weather, it's usually always hot there. Traveling, if you took a plane or if you got stuck in traffic. But don't rush the building relationship, because Brazilians are big on relationship building, because they like to know the person personally, because they're relaxed. This is actually a hotel that there's a lot of business done, like meetings, Sheraton Hotel. Barra is a place in Brazil, one of the more popular places, and apparently has magnificent views. So, like I said, Brazilians negotiate with people, so face-to-face meetings are always better rather than on the phone or over Skype or any other way. The individual is more important than the company, but you will get asked questions about the company. And the legal contracts, they are very detail-oriented. So, they don't like outside legal people, so try to get Brazilians or people from Brazil. If you don't speak Portuguese or if you don't know Portuguese that well, get a translator who knows the language and who knows the language of legal and accountants for negotiations. But the negotiators don't make the final decisions because it's a hierarchy in the business system, so the person with the highest rank makes the decisions.
Alright, I'll be guiding you through meals during business. Eating is very frowned upon during a meeting. It's considered impolite to be chewing while you're trying to have a conversation. So usually people just drink water or coffee as previously stated. It's very common to drink the entire time, however eating, even if it's during the lunch hours, is highly frowned upon. As for dining, the host always picks up the bill. If somebody invites you out for a meal, you can expect that they are going to pick up the ticket. The meals are usually fairly lengthy. They're about 2 hours or longer. Definitely don't expect to be out of there quickly. And as a guest, you're not supposed to bring up business. Oftentimes the business dinner there's very little discussion of business at all. It's more of a bonding experience. A host can bring up business, and occasionally they will. But as stated, most of the time you do not talk about the actual business. Your appearance is very important in Brazil, so you'll have a meal at a prestigious restaurant. And when you're staying there, you should splurge on a high-class hotel. How you present yourself is very important, even if it's just where you're sleeping for the night. Occasionally, at the end of the meal, the host will take out tourists. Like if you are not from Brazil, you can go to the famous Christ the Redeemer statue. It's probably what we all think of when we think of Brazil. They'll bring you to see sites such as that, or Sugarloaf Mountain, or Ipanema. And thank you very much. That's Brazil.
No, we're doing countries first.
Did I get your presentations, or is that what you're doing now?
They're on here.
They are.
Yeah, it's not quite.
So you're gonna go?
Who's going first?
That is poor business ethic. Standing in the chair,
All right. Yes.
No, you do what you need to do.
I will not do that.
You're exactly my point.
Okay.
So this is the Honda Davidson. This project actually started a couple months before the project's cost was assigned. As many of you most likely know, I'm an electrical engineering technology major, but my hobby is mechanical, so I've been tinkering around with this particular device. This is actually a series of videos that I've put on YouTube of the entire procedure. You can see we've been doing it for a number of times. Started off with a tricycle, decided we're going to put a motor on it, and very recently decided I want to add electrical capabilities to this particular device. This is me working on the device. This is an action shot. So everything we built for the most part is scrap. So the average cost went up significantly from this project. Aside from the motor, that's not scrap. We bought the motor. Almost everything else, the Honda comes from its old Honda bike, and the Davidson is some scrap Harley Davidson handlebars. So I found this circuit online. It's just a single blinking circuit. There's 6 LEDs, or there's 10 in this circuit. I thought that was a bit much, so I cut it down for mine. There was several other like extraneous pieces of this particular circuit, and I didn't see much use in just one strobe. So I duplicated the circuit, as seen here, into a left and right segment, and brought them down to 6 LEDs on either side. You can't see, but these are headers, so each one of these goes to 2 LEDs. This is a header for the battery, and then the directional switch. But I used a calculator to figure out what my RC value would be. The one on the website I found had it on for about 6 seconds and off for 3. And that's not a very effective blinker method. So I recalculated it down to where it will be on for 1 second and off for 1/3 of a second. Most of my parts came through Mauser. I bought a couple of things off Amazon, such as the batteries, some enclosure pieces. We used the advanced circuits to get the circuit board. Most of you know this, you went through the procedure. But using the advanced circuits website, we were able to get a custom circuit board. This is my circuit board. It came back and have it all laid out, so the left section, the right section above. This is early putting it together. I started with the more complex pieces, that way if I messed up, I didn't have to worry about having a lot of components already on here. These are my 555 timers. Then I have the transistors, resistors, capacitors, and diodes. This is it inside the actual enclosure. I had a series of headers. You can't see the enclosure, it's actually underneath this particular thing. I started off with a metal enclosure, but it was damaged. So ended up, I found a waterproof enclosure that is typically intended for sandwiches. However, for me it's intended for circuit boards. I chose this particular design because it's lightweight, easy to work with, and I sealed all the holes with the silicone, so now it's still waterproof. And I can remove the lid if need be to easily access the circuit board for repairs. That's the end of my presentation. I can display this to you using my user manual decisions. To use this device, you want to plug in the battery. I would recommend against leaving the battery hooked up most of the time. You might not be able to see this up there, and I'm not going to pick it up because it's sort of heavy. But there's a switch in the front, so you can indicate which direction you are turning to. This is chances are, if, can you see?
No, do it to the other side.
Do it to this side. Can you see that? This is primarily a safety thing. If for any reason we're on the road at night, I wanted people to be able to see us and where we were going. Other things I wanted to add to this project, but I didn't have time or the funds for it, include headlights and a horn. Those are somewhat extraneous. They didn't add very much to the actual project. Adding a light into a circuit is not exceptionally complicated. That's what I hope to add in the future. Many people have been asked this. I'm just going to answer the question ahead of time. If I had another semester to work on this project, I would like to, and more money, I would like to use a microcontroller because if you've seen some of the Mustangs have the blinkers that they stagger the 1, 2, 3, 1, 2, 3. I think it would be interesting to try and set up something like that. That was more than I was willing to bite off for this particular project, but I think it would have been an interesting addition. As far as actually attaching this can go on any device. It can go on a bicycle, it can go on a car if you wanted, even though it's not very necessary. I used a series of removable zip ties for easier maintenance or to transfer it to other devices, but you can use screws or whatever mechanism of attaching you desire. I did not want something so permanent. Is there any questions for me?
What was the most difficult part of your circuit?
For me, the most difficult part was getting the 555 timed correctly. I had a couple issues with that in the beginning. It turned out it doesn't time correctly if the entire circuit isn't wired to it. That's because of the way that the transistors work. The 555 acts as it turns the transistors off. It uses them as a switch to add and remove power from the LEDs. It took me a while to figure out what the entire purpose was going on there, but I was able to resolve it. Anyone else? Good one?
What was your inspiration for building that?
This thing?
Yeah.
There's a TV show, it used to be on MTV, called Nitro Circus, where they took a big wheel. They were trying to do backflips and they kept breaking it, so they made one out of metal. And that was our original inspiration. We had this as a tricycle. The wheels used to actually be up here. And then we thought, this is kind of fun, but we need to do better. My brother and I like to goof around a lot. Most of what we do is mechanical, just nonsense. This was an easy way to do that and a cheap way to do that. You can probably, most of us on here, we use skateboard wheels as bearings, and we use carbon, anything that we could. It's mostly just what can we do the most of for the least amount of money.
Can I see it working? Because I couldn't see.
You can't see it? It's kind of low down. I might need to tip them up. But they go to either side.
Now I can see it.
You can see the.
Yeah.
I think 2 of the LEDs are out on one side. One of the leads snapped off while I was wiring it, and it was super glued into place. So I can remove that and I can add in a new one.
So when you apply the brake, you do it again?
Right now it only goes to one side. I realized earlier it would be nice if I could have a switch up so you could just have both of them on. That could be something to add in the future as well. Currently only one or the other is on, but it would be nice to have both.
Okay, and you could add John's feature of having it flash then too? 'Cause
Yeah.
That's what his circuit does.
Exactly. Oh, you built a flasher? Spoiler alert.
Okay.
Anyone else?
No, they didn't charge me more. Banks overdraft, they charged me more.
How much is your overdraft?
$33. Yeah, so apparently, advanced circuits.
I'm going to need, Ms. Dagan, I'm going to need 2 plugs when I go to
Are
bed.
there 2 plugs in there?
The other one's powering.
They said it's gonna be $102 after they recover the
Yeah, I care. So, yeah, we don't want to unplug the computer. So why don't you can plug in the side, the wall outlets there?
What? It runs now. It's just, you can't use.
It's worth to being a freelancer. Everybody wants to, but you don't get paid enough.
Yeah, we could be debating between the handle thing or maybe just doing a lever. Do that. Figure it out. While it's pushing it back, push up and actually pop the chain off. Easy enough to pop the chain back on.
You know what it is, they could have done it with him.
We haven't really been
Questions?
Jeff, before you begin, can I just ask that you maybe share a life lesson with the class and
All right.
backups and plan on things
Absolutely.
going wrong at the last minute, because it always happens, and have a plan A, B, and C when doing a presentation, always.
Right.
I'm just
Actually repeat
yeah, just
that?
explain
Alright.
that, because
So,
it can happen to
I will
anyone.
not have anything on the projector screen because I rushed at the end to do my presentation, and when I went from going from my laptop to the school computer, none of my slides saved. They all got wiped. So I am SOL at this point, and I will just be winging it, unfortunately. But I know my circuit very well, and I should be doing a good job.
You will.
What happened to me where it screwed up the formatting on the,
Well, exactly, it happens to everyone, so that's why I say, the key thing is how do you react and respond to a not the ideal situation? Do we just scream and give up, or do we persevere and still accomplish what we need to do, and that's why you're here right now, so thank you.
Sure. Alright, so does everybody know at one point in their house those plastic blinds that you use them once, you put them in the house, and as soon as you use them, they're broken. They're in 17 different pieces at 40 different angles. You all know what I'm talking
Oh,
about.
yeah.
So instead of messing with that by hand and standing there telling them to do it, wouldn't it be a lot easier if you had some sort of automatic control that could run that window curtain up and down? Or this projector, instead of, I'm going to mess this up, I'm not going to be able to raise this up. See, I can't even control this. I don't know how this works. It's beyond me. Again, wouldn't you rather just wave your hand and the thing magically goes up? That's what I made a wireless control circuit. I went online and I found a circuit that uses a light-dependent resistor. It's on the side here. So when you block the light, it goes through an op amp. The op amp, it's a signal comparator. So when you block the light and change the resistance from that, the op amp will go from outputting a usually high signal to a low signal. That low signal feeds into the 555 timer there. So when that triggers, it's going to output, it's in monostable state with an RC time constant on the side. So it's going to output a pulse to my JK, which is in toggle mode. And it is simultaneously going to output that RC time constant pulse to a tri-state buffer. When that JK flip-flop is outputting high on J, it allows Y1 through the buffer to output the signal to one of two relays. When K on the JK is activated, it will output a high to the other of two relays. And again, it will be on for the duration of the 555. That's the motor control portion of the circuit. That's what I decided. That way, because I have the relays independent of the power source for the control system, it gives you a lot more freedom to put a larger motor on or to put stronger relays, whatever you want to do. So if you need something a lot stronger to control this very heavy screen here, or if you want to just whip out a whole bunch of toilet paper real quick, which is what I tried doing, but I couldn't figure out the gears. You have that freedom to do that. So you have a lot of play that way because I separated it. Mine utilizes additional relays to normally open contacts that will send polarity to a DC motor for clockwise rotation. And when the K is activated, it will send the other relay power to reverse polarity and go in counterclockwise rotation. That is the theory behind this, and I'm very proud of actually getting it because the circuits I found online, I basically changed the whole thing. The first part of it that took the light and was controlling a switch, it had a JK instead of the 555 I put, so it's going to be one pulse signal. You can't control the time. I didn't care for that. I wanted to have control of it. The motor control portion had a D flip-flop in toggle mode with a Darlington array that stepped up current. And for the life of me, I couldn't figure it out because I didn't plan it. I didn't make it. It wasn't my idea. So I started over. I created it the way that I explained earlier. That way I know it. Like I was able to explain every step of the way. It was easy for me. So I am at the point where I will demonstrate it to you guys. Unfortunately, I'm not a mechanical engineer and I couldn't figure out how to get a toilet paper roll attached to my plastic gear here. But it was not for lack of trying, I promise you that. My DC motor is 12 volts on the side here. So I have a 12 volt AC adapter from 120 to 12 volts DC. This is the control portion. My control circuit needs 5 volts DC to run, so I have a 120 to 5 volt that comes in the side. Since this is a light dependent resistor, and it is very dark in this corner, does anybody have a light on their phone that they are willing to lend me very quickly?
So we could put the lights on too, I don't know if that'll help.
I'd rather a flashlight.
Okay, make sure the sun is shining in that corner.
So I have 2 potentiometers on the side. This potentiometer is, oh, you got the heavy duty one. Absolutely, I'll take that one. Absolutely.
I come prepared.
I'm in. There you go. All right. So this box here has 2 potentiometers. This potentiometer, it adjusts the sensitivity because again, light is not constant anywhere. Right in here it's darker. If I go to that corner of the room, it'll be a lot brighter. So I'm going to need to adjust the sensitivity on it. Even with no light, if I change the sensitivity enough, wait for it, I better do it. I'm going to be so mad if it'll go on. It'll just go on without any light or anything like that, without being triggered. So again, you want to adjust the sensitivity. This one here, it's the RC time constant, adjust the time. We'll get to things I'll do differently with that later on, but at this point I'm just showing you the functionality. So if I have a light on my resistor right here, and I block it, I will adjust the sensitivity till it just goes off, and that's when I'm going to know that'll be the most opportune sensitivity for me to activate the circuit. It takes a second to fine tune these things, you know, machinery and all that. Not ideal, I'd say. I was going to keep moving away. I'm just not intelligent is really the reason that this is happening. Alright, so there we go. When we block it, we'll have it go in one direction clockwise. That way, curtain will go up, whatever. Whatever you have going. And again, it's not working. Alright, hang on. One more time. I promise this will work. Alright. Nope. Well, alright, that's the logic of it. It's going to go in one direction when you block the light, and next time you block the light, it's going to go in the opposite direction. The thing I would change, I have the timer here. I have it in series with a 5.6K, which originally was going to be for a curtain, so there's a lot more distance, but this, I want to have a lot more control over the time of it, because say you put a toilet paper roll, the entire roll is going to be gone at the rate that that's spinning, as I found out a few times. So that is one thing I would change. Also, I would learn how gears and rolls work, so I can actually show something that works. Also, I would plan out ahead of time so I don't spend all the money on the components that I'm going to take out of the circuit and not use, because I am a lot heavier financially into this than I should be. And honestly, that's about it. Do you guys have any questions for me? Very good. All right.
All right, thank you.
Yeah. Thank you.
No problem.
Jeff, can you pose for a photo op?
Photo out. One like that.
Want a real one too?
And then one.
Yeah, a real one.
I'm not a good photographer.
over investment. You know, maybe though, if they refund that 86, that'll cover all the overdraft fees that incurred too.
So this is actually not my project, it's just the box that I carried it in, but everybody's like really wants to know what's in it. I'm just gonna wait till the end to open it though.
So we're kept in suspense the whole time.
It's really nothing that great, but I think it is.
No, wait, can you restate that?
Yeah, it's the
Restate
best thing
that.
you've ever done in your entire
Remember
life.
all our conversations on the confidence?
No,
If
my
you don't believe
bosses,
it, we're not gonna believe it.
my bosses thought the enclosure was great. I personally thought, because Brazilian, detail oriented, I think it could have been better. Just the laser cutter didn't want to work with me. So my project description, I put 2 circuits together. I put a rain sound generator, sleep aid generator, with just a simple LED circuit with the globe on top, poked with a bunch of holes for stars. This is the original circuit that I found. It called for 12 to 30 volt power source with headphones, but I changed it very slightly. To this, I added 2 9-volt batteries, an on-off switch, and 2 speakers, 8 ohms each, so a total of 16 ohms. And this was the circuit that I found for the LED, but when I tried it out, from the beginning I thought 1.5 ohms was too low, and it was because I burned my finger when I touched it. So then I just came up with that, easy peasy lemon squeezy. That was the changes to the original. So I had 2 circuits. I added 2 speakers to the rain sound generator, 2 batteries to the rain sound generator, created the LED circuit and switches to each circuit to control, to have it on or off. And if you either wanted just the LED or just the rain sound generator or both of them on at the same time. This is the PCB layout with all the traces together. My pile of parts. Tools needed. Soldering iron. I kind of left it on too long, even with the tip with the solder on it, and I burned it. The hot glue gun was my best friend. This is the laser cutter. It looks like it would work very, very well, but it does not. I had to make measurements about 3 times for the front, where I would put the switches and the potentiometers. And even with the specs that was given by the data sheet, it didn't fit. So the switch was 0.315 inches, and I put it into the laser, not me personally, put it into the laser cutter, and the switch would not fit. So at the end, it was needed to manually do it on the laser. I used thin wood for the top and the bottom layer, and polyglass acrylic, red on the front and back, and dark gray on the sides. This was the beginning of the process of breadboarding. This is my 741 op amp. This is the 100K potentiometer that adjusts the tone. The 47K potentiometer is floating up there, right there. The switch, the batteries that go, this right here in the corner is the LED circuit, and the speakers that are in the right bottom corner. That is the full circuit actually working. The speakers were on, you just can't take pictures of noise. I ordered 2 boards just in case I messed one up, and I almost did use it, because when I soldered everything, my circuit just didn't want to work, either of them. But when I was troubleshooting it, I figured out that I followed these diagrams right here, and I did the longer lead for the LEDs on that side, and it didn't work. So I had to cut the battery wires and just switch the polarities, and it worked. And then what actually was wrong with my sound generator was that there was a short in a potentiometer, and it was burning up my resistor 7, which caused it to change a different color and to have smoke and a burning smell. But once I figured that out, it actually worked pretty good. So this is the resistors and the capacitors. I started off simple. This is the PCB soldered, the resistors, capacitors, and the 741 op amp over there. This is what it looked like when I was testing it. The switches and potentiometers are down here. They were just hanging off the table and couldn't fit. This resistor right here was the one that was changing colors. I don't know if you can see it's darker in the middle. So when I was drilling the holes on the dome, which was originally a light fixture, I asked my brother to take pictures. He became a photographer all of a sudden. He got behind my hair, focused in on the dome. He made me even put the towel on the bottom. This is actually what the enclosure looks like. These are the holes for the speakers. There's one on the other side. This is the switch for the sound generator. This one's for the LED. This is the volume. And this is the tone control. I forgot to take pictures, so I had a classmate take pictures while I was doing it because I almost put the top on without the pictures of the board inside the circuit. It was very hard to have this in here and wire all of this up because this circuit board was actually standing on some homemade, like pillars, I guess? Standoffs. Made it from pens.
Oh, good.
My boss's idea. This is the final product. This actually right here was spray painted and it had the paint tape all over it. This is what it looks like. Since it is a sleep aid generator, it's very quiet because you're obviously going to be listening to it when you're sleeping or going to sleep or trying to sleep at night by yourself. And the lights, you won't be able to see them in here because they're too bright.
Should these help fill it help at all? Or?
It's too bright in here, but it does work. So this one's the sound. I don't know if you guys can hear it. I'll walk around with it. Yeah. You hear it? It's just like white noise. The LEDs are actually on. You heard it before?
Yeah.
You heard it. Some things that I would change would be the LEDs. I used 4. The original one called for a 3-watt LED, but when I bought a miniature size surface mount one. And when I tried to solder wires onto it, it exploded. So, yeah, that would be the only thing I'd change. And to try to make the actual generator sound louder. Any questions? No, that's it. Thanks. Any questions?
What was your favorite part of the project?
Oh, poking the holes in the dome. My dad gave me a great idea to get a nail, heat it up, and poke it. So I obviously drew the constellations on it before, and then I just sat on the stove and they kept poking the holes. But honestly, that was my favorite part because it was the least amount of stress.
Well, what did you use for the dome? What is it?
The light. That's
what that is?
So I had my boyfriend cut it. Actually, I wanted to go to Home Depot. He didn't want to because he said they were written by the data sheet. It didn't fit, so the switch was 0.315 inches, and I put it into the laser. Well, not me personally. Put it into the laser cutter, and the switch would not fit. So at the end, it was needed to manually do it on the laser. I used thin wood for the top and the bottom layer, and polyglass acrylic, red on the front and back, and dark gray on the sides. This was the beginning of the process of breadboarding. This is my 741 op amp. This is the 100 K potentiometer that adjusts the tone. The 47K potentiometer is floating up there. Right there. The switch, the batteries that go on. This right here in the corner is the LED circuit. And the speakers that are in the right bottom corner. That is the full circuit actually working. The speakers were on, you just can't take pictures of noise. I ordered 2 boards just in case I messed one up, and I almost did use it because when I soldered everything, my circuit just didn't want to work. Either of them. But when I was troubleshooting it, I figured out that I followed these diagrams right here, and I did the longest lead for the LEDs on that side, and it didn't work. So I had to cut the battery wires and just switch the polarities, and it worked. And then what actually was wrong with my sound generator was that there was a short in a potentiometer, and it was burning up my resistor 7, which caused it to change a different color and to have smoke and a burning smell. But once I figured that out, it actually worked pretty good. So this is the resistors and the capacitors. I started off simple. This is the PCB solder, the resistors, capacitors, and the 741 op amp over there. This is what it looked like when I was testing it. The switches and potentiometers are down here. They were just hanging off the table and couldn't fit. This resistor right here was the one that was changing colors. I don't know if you can see it's darker in the middle. So when I was drilling the holes on the dome, which was originally a light fixture, I asked my brother to take pictures. He became a photographer all of a sudden. He got behind my hair, focused in on the dome. He made me even put the towel on the bottom. This is actually what the enclosure looks like. These are the holes for the speakers. There's one on the other side. This is the switch for the sound generator. This one's for the LED. This is the volume. This is the tone control. I forgot to take pictures, so I had a classmate take pictures while I was doing it because I almost put the top on without the pictures of the board inside the circuit. It was very hard to have this in here and wire all of this up because this circuit board was actually standing on some homemade, like pillars, I guess?
Standoffs.
Standoffs. Made it from pens.
Oh, creative.
My boss's idea. And this is the final product. This actually right here was spray painted and it had the paint tape all over it. This is what it looks like. Since it is a sleep aid generator, it's very quiet because you're obviously going to be listening to it when you're sleeping or going to sleep or trying to sleep at night by yourself. And the lights, you won't be able to see them in here because they're too bright.
Shut these off? Will it help at all? Or?
It's too bright in here, but it does work. So this one's the sound. I don't know if you guys can hear it. I'll walk around with it. Yeah. You hear it? It's just like white noise. Oh, the LEDs are actually on. You heard it before.
Yes.
You heard it, you heard it. Some things that I would change would be the LEDs. I used 4. The original one called for a 3-watt LED, but when I bought it, I bought a miniature size surface mount one. And when I tried to solder wires onto it, it exploded. So, yeah, that would be the only thing I changed. And to try to make the actual generator sound louder. Any questions? No? Good, thanks.
Any questions for Eduardo?
What's your favorite part of the project?
Oh, poking the holes in the dome. My dad gave me a great idea to get a nail, heat it up, and poke it. So I obviously drew the constellations on it before, and then I just sat on the stove and then kept poking the holes. But honestly, that was my favorite part because it was the least amount of stress.
What did you use for the dome? What is it?
The
Like-
light.
Oh, that's what that is?
So I had my boyfriend cut it. Actually, I wanted to go to Home Depot. He didn't want to because he said they weren't going to do it because if they break it, they were going to have to replace it. So I made a deal with him. He could do it, and if he broke it, we would go back to Home Depot. They would do it, and he would reimburse me, obviously. So he did it, and he actually got it the first time around. But there was like a little hook on it, and he wanted to saw it off again. I didn't say anything because he never listens to me. So when he puts the saw on it, crack, it just breaks in his hand. So we go back to Home Depot, we buy another one, he was able to do it. This time he didn't try to saw off any hooks. But yeah, it was just the fixture that you put on the lathe.
Thank you.
So we choose our company's name, EET Solutions. It was actually Kevin's idea. He kind of like ditched us and we left. So we chose Germany. So the reason why I chose Germany is because it's a great deal for importing. It's one of like the second largest country in the world for electronics, to do business for electronics, and you can make a lot of money there. Like selling, all the main big stores are in Germany. Besides Apple and everything, that's American. But if you want to go for electronics, more of electronic kind of products, that's the Germany. That's the place you gotta be. So the next one is the language.
Well, the way they do business is more like a serious kind of stuff. There's no like getting to know you. You gotta like, it's either you get there and shake hands and talk to them about the job. With them, you gotta have a lot of eye contact. Like, it's a show respect, and if you're not, it shows them that either you're bored or you're not interested in what you guys are talking about.
So the next one is language. So as we all know, German is the official language, but besides German, like only almost 100 million people over there speak German. Besides German, they also speak languages like Serbian, Danish, Frisian, Turkish, Kurdish, Polish, and but the Russian is the most spoken language. Besides the Russian, like in every school there, they have to choose second language like us here in the United States, and English is one of the languages most of people use. So you don't have to know German if you want to go there and do business, but if you know it, that will be a plus point, because all the business people over there, they know English pretty well.
Well, face-to-face communication. You need to always look at them, always have respect. With them, they do look at how it's non-verbal communication. So you have to be serious. There can be laughing or joking around. That's pretty much it for that.
So we put more into non-verbal communications. And then there's a verbal communications. So, like, do not call people after 10 o'clock. Basically, it's a rule of thumb that you don't want to do that at all. So, their work time is usually Monday to Thursday until 5, 8 to 5. And on Fridays, they leave at 4. So you don't want to call them after 5 on weekdays and on Friday after the 5. And so most of the people over there, they will say their
by the first name, they all go by the last names. First names are basically like more of the family or friends. And they're time reserved and direct people. They will say direct on your face if they don't like you. They won't like say on the back or something. They'll just say it on the face that we don't want to do business with you. That's it. So it's personal titles. That's a big thing over there. And like, so you want to say there by the full name, correct titles and everything. Like Mr. over here, over there is referred as a her. So if you're calling someone her, so you say Jeffrey, her Jeffrey. You want to say Mr. Jeff. So let's go by last name. But if it's my friend, I'll say Jeff. We won't say Mr. or her to that. Like Dr. Fra, that's female. So say Fra doctor. Like we always say, doctor, like last name. But over there, Fra comes first and then doctor.
Punctuality, it's a big thing with them. Like you can't be late. You'd rather be early than late. Like everything, even like their trains go like by minute. It's not like they're really thing. And like if you do turn out late to a business, it's way disrespectful for them. So like if you are going to be late, you do have to call and like make sure they're okay with that. But besides that, it's pretty much for the job and then business. The dress code. They wear suits and ties for guys. Girls can have like pantsuits or skirt and a nice like dress shirt. That's more like for like a business general kind of occupation. And then for like factory workers, they wear like blue suits. Like one of those big blue suits.
I just want to add to the dress codes. I went to India this December and my stayover was in Germany. Over there, the thing that I found was like people at the airports, everyone was wearing suits. Like literally every single person was in black suit. There was no one, like I was the only person wearing shorts and everything, but there was no one wearing shorts, sneakers, everyone was dressed up all the time.
Is that when they're traveling they dress up, or you just think
they
they're
dress
just...
up basically all the time. If they want to go for dinner, they will dress up.
So Americans would really stand out because
Yes.
we're in our jammies all the time. Yes. For jeans and a t-shirt.
So, business meeting tips: lower your voice a little. Like you don't want to talk with anyone with a louder voice, especially if you want to do business with someone. You want to be calm, and they have a privacy and personal space. Do not ask personal questions to them. It's strictly business. They don't want to talk anything about your home, anything about your friends. Even if you are a friend with them, they will not talk with you at the business. At a business meetings, it will be all business talking over there. So a man or a younger person should always walk to the left of a woman. That's a big thing over here. And like if a big person or a boss walks in, everyone stands up. And when the girls do, women also have to stand up to respect an elderly too. So always grade women first in German, instead of if there's a male and a female coming in for a business. So German will also always grade a female first and then a male. So that's pretty much it.
And we added the currency. Like the euro is worth $1.13, and then the US dollar is 87 euros.
So you will make money out there, but it won't be that much as compared to other countries. But it's worth it as the amount of business you do over there, because you can sell a lot of electronics down there. I'll sell a lot of electronics rather than selling less for more price, I guess.
Very good, thank you. Yeah. So Carlos is up first, I see.
presentation about a motor control. So this is the original schematic. It's using MOSFETs. How this works, this MOSFET right here is a PNP, and this is a NPN. So whenever this is high and this is low, the motor will be running forwards. So this one will be on and this one will be on. This will be off. And it will be backwards for the reverse. But if you have both of them on high, the motor will be floating. So there will be like positive 12 volts and then negative 12 volts, so it cancel it out. It won't move. Why I added to the design was reverse polarity protection using another MOSFET. And then I kind of changed this from what this looks right now into there. So this is going to display which direction the battery is connected. The green is going to display it's right, and then the red is going to say it's wrong. Once the red LED is on, there won't be power through this because it will just go through here and it won't go through the project. This is my breadboarding. There's a lot of things missing because I took a picture after I put it all together in here. So the motor's not here, but it's supposed to be right here. Then soldering part. This is where I was just starting to solder, and as you can see, this is all done. I did have a little issue after I soldered, because, and as you can see, that's the top. These black things is for the heat, because these MOSFETs are really powerful, because I do plan on like working further into it. So they go up to like 240 volts. So it's really good MOSFETs. This is when I started working in my auto pace. That's how it was. Had to add the wood here, so because this moved when you press it to go forward reverse. So I had to like safely put it there, and then I put that up in there, and then that's how it looked at the end. This LED will show going forward because I couldn't figure how to, didn't work the way I was trying to put. So I was trying to do a flag and that's what I was going to do it, but it wouldn't work. So I added 2 LEDs to show that. The problems, like I said, I had an issue. The footprints were wrong, so I went when like I thought it was right, so I hooked it up how it was supposed to go. But I had a lot of troubleshooting because I didn't think it would be that, so I had to take measurements of pretty much everything. And then I went through the traces because I talked to Mrs. Dagan about it. And I went through the traces and I saw that one of the leads were supposed to go to that one, right here. This one was hooked up here, this was hooked up here. So I had to switch around, so I had to work with that. But after that, it worked perfectly. I'll display it. As you can see, this side, I have an on and off switch. So that's going right. So once you press this one, slowly picks up speed and it's gone. And then for the reverse. And if you press both, as you can see, both LEDs turn on when the motor doesn't run. So for the part that I added to the project, the red LED comes on, the motor doesn't run. That's pretty much it. Thank you.
So what's your, do you have an intended application for this motor controller?
I kind of wanted to do like a remote control for my little nephew car.
Mhm.
So what I'm planning to do is like do another one so I can do like left and right. So I'm working on that.
All right, good, thank you. Any other questions? All right, just Karen is up next.
So I worked on fire alarm. It's not basically a fire alarm, it's more of a heat sensor. Senses the heat and senses signal to 5-5 timer, and you able to listen to sound. So that's basically what it looks like on the inside of it. So technical specifications, rather than saying it, I went on writing everything on. So fire alarm, it alerts us when there is a fire accident by sensing the heat of fire from a thermistor. That's a 10K thermistor, and generating the buzzer sound. And the fire alarm panel is a central processing unit of the system, which receives and analyzing the system. So a user can listen to a signal and go there and work on getting the fire off, but you won't be able to turn the fire off until the power is turned off completely from the whole circuit. So you gotta turn the power off first. So that's kind of cool thing about it. You can't just literally, if there's no fire, if there's a fire and some reason the fire goes off by itself, the circuit will not go off. So someone will have to come in and will have to turn the power off and check in there if there is something bad. So I put on the minimum pass required. So there are like 7 resistors you need, 3 capacitors, 5-5 timer, 3 transistors, a diode, and a speaker. So technical descriptions. So it's a heat sensor. So when temperature increases on the thermistor, it actually decreases its resistance. And at normal temperature, it's approximately 10 kilo ohm, and when the temperature decreases, it decreases like pretty less. Go beyond 100 degrees. We'll turn the transistors on, T1 and T2, that's PC 548 and 558. And that signal sends to 5-5 timer. That further sends a signal to a 2N4922G semiconductor transistor. That 5-5 timer is generating a sound, and that T3 transistor is the one that is making the speaker on. So went on breadboarding. It's pretty much wasn't a lot of components, but I used a bigger space. The issue that I had with this was I wasn't able to get a loud noise that I was having through a breadboarding. What I thought about it was it's because of the size of the board, because I didn't thought about it before. But the size of the board is 2x2, I think, the smallest one. If I could have a 3x3 board, that would have given them more signals to go through. For this circuit to work better, I have to add filters in it. Filters any 5-5 timer, and that will give us some more sound. We'll be able to listen to the sound. But this circuit in here in 2x2, I wasn't able to. I was able to hear it, when I'm really close to it. We won't be able to listen on a large scale. It's basically the PCB editor, bottom solder, tops. Before I sent it to the advanced manufacturing to get my board. It's a printed circuit board. As you can see, there's some traces in here that are missing. That is just because of the board. It's too small. If I would have a bigger board, we would be able to see all the traces. So, issue circuit while assembling. All the transistors over here that I had all of these plugged in wrong when I started them. I made it instead of collector where it's supposed to go, and these two and this other one here. So I have desoldered pretty much all the entire board, all the capacitors, all the transistors, my thermistors, and I have to put them back in. I have to go through traces, I have to work a lot on that. And finally I got it to work, but it wasn't the best. So I worked more on the presentation part than on that, because there was pretty much nothing that I could do, because I figured that out last week. So other application that I can use this same circuit for. The same circuit can be used as a heat sensor, it can be used as a temperature control room. So say if somewhere they want to set the temperature to 30 degrees Celsius, I'll say, 60, 65 Fahrenheit, they can put this circuit in with a temperature sensor on it, and every time the temperature increases or increases, this will make an alarm sound telling the person to go and check the temperature. This circuit can also be used as a light sensitive device, or light sensitive, like Jeff had. Basically, I didn't have an J and Ks in there, but pretty much if there is no light, if there is light the way you want to make it, then the circuit will make noise. So telling the user to go and check the area to get it to work. So final assembly. The sheet I had under here, it's too thin. When I tried to drill it, it kind of made it unbalanced. So that's basically the main reason why it's not going, and also the screws. Final assembly. That's pretty much it. As I said, conclusion, I'm not having the loud noise. So what happened in the morning, I retested it, and because of that, I put too much voltage in. The cool thing about this circuit is it can work from 4 to 12 volts. So you can pretty much change your voltage, DC voltage to any of it, and it will still work. The only thing is for the LED, I have to add another resistor to make it work better, to make it stay longer, I'll say. Pretty much it. I mean, the half of the circuit is still working. That is, like you can see the LED turn on inside, but you won't be able to listen to any noise at all. Like all the capacitors and everything got blown out of it. As you can see, LED inside is lighting. So this thing I added up here is the sensibility. Say you went to a really, really warm temperature, and over there, this circuit will turn on itself by itself. Oh, it's working now. It's like really, really less. If you come here, you can listen to it. But there's a little bit noise.
So right now you have it adjusted to,
Like less resistance. All the way to this.
oh, I can hear it. Okay,
So if you go to like a really, really less temperature, so you can adjust this circuit to the sensibility of the circuit, and if you need to have that much heat to get the circuit turned on, and say if you're at really high temperature, you can adjust this so when a little less heat hits it, this will turn the circuit on immediately. That was pretty much it.
Question for you off the record. So to get it work, because on the breadboarded circuit.
Yeah, on the breadboard it was pretty.
Yeah. So how much effort do you think it would take to get that?
This thing working?
Yeah, if you had to revisit it.
I'd say no more than 2 weeks. If I would have more than 1 or 2 more weeks. So yes.
So you did prove the concept, I remember. So okay.
I mean, the main issue was the board. Like it's too small to work with, and also all the desoldering I did on it.
Okay.
So it kind of like not the best way we started.
Okay.
it,
Well,
but-
it's, again, it's a prototype, so in the real world, as you know, do you think any company, their first revision is what they end up selling to a customer? Absolutely not. You gotta get the bugs out. So yeah, we'd go back and revisit this if we had another semester, but unfortunately we do not. So thank you, Ms. Karen. Any other questions before we change it to John? Did we save the best for last? John, and I need to get your files copied over. If you could do that for me, please. You don't have plan A, B, and C. Remember how it's not? This information was handouts, just in case you leave it for page 2 or something. So just quickly, but she likes some sort of.
Really? There we go.
M squared.
Is it just you though?
Hmm?
Is it just you?
Well, originally I did have a partner. He's not in the class anymore.
Oh.
So originally it was Miguel.
Oh, right.
And so it was McManus Martinez, and we came up with M Squared Enterprises. We're talking about cultural business practices and business etiquette. Our target for our foreign business target is Slovakia. Slovakia was formed in January 1st of 1993 after a dissolution of the former Czechoslovakia, which formed the Czech Republic and Republic of Slovakia. It approximately has 5,400,000 people as in their population. They have a GDP as of 2015 of was 158.428 billion euros. That's the second highest grossing GDP in the Euro Union, other than Estonia, I believe it was. So they're very proud of that fact. Also, as you'll see here, the capital is Bratislava. And they're starting to get a lot of American influence, as you see by this picture. Obviously, from I Love New York, you're getting I Love Bratislava. They're very, very personable people, which is, they're friendly. So it starts with the greetings here. When you meet a new or existing business clientele or your partners that you're working with there, you always want to look them in the eyes. If you don't look them in the eyes, they think that you're hiding something. Then you want to go in and give them a firm handshake. If you don't give them a firm handshake, they think that you're weak. So no eye contact, they're going to think you're hiding something. No firm handshake, they think you're weak, you're never going to get a business deal. After greeting everybody in the room, you go around, and there's no particular order. That's usually dictated by the host that set up the meeting. You greet everybody, remain standing. What they usually normally will do in a meeting is designate a seat for you that's reserved specifically for you. So you go greet everybody, introduce yourself, hand out business cards, then please take a seat. As far as greetings continue, gifts or flowers, there's a policy that they have over there that's universal in most of their business culture. Small gifts are nice. Nothing extravagant, nothing expensive. Usually flowers, a bottle of wine, maybe a business gift, something that represents your company, or a small gift, like say a book or a souvenir from where you come from, the country you come from. Then comes the dress code, as everybody else has touched upon, especially like Germany and the European countries. Slovakia is the same way. They're very, very conservative in how they dress, and that's whether it be for work or for any type of business function. Men, they want conservative, reserved attire. That means dark suits, nothing bright as my shirt, but what Patrick had is wonderfully acceptable. That's what they want. They don't like a lot of jewelry. A watch, a ring, that's it. Earrings, big no-no. Women, again, conservative, either a pantsuit or a skirt suit, black, gray, dark color as well. And one thing with that, no provocative clothing. For these meetings, you want to be punctual. Punctuality is key with them. They will give you, if it's a informal gathering, they'll give you about 15 minutes leeway. But if it's anything business, they want you there 15 minutes early. If not, you're not showing respect for your company and you're not showing respect to them. Then that's going to be an issue as far as if it's going to gain business or not. Setting up a meeting. With meetings with them, they want them set up in advance. So you'll usually email a contact that you have with that company, usually about a month ahead of time. Set up the meeting, everything will go smooth. About 2 weeks prior, you go ahead and you call them back up, see who's attending. If you're going to need a translator or not, that's very key. Depending on who's there, who will be attending the meeting, will determine if you're going to need a translator or not. Now with the way things are going with a lot of the Slovaks being westernized, the younger generations speak English very fluently, so you won't really need a translator at that point. But if you're dealing with an older generation, you will oftentimes, they will know some English, but you will need a translator. Some things to know when you're doing a meeting with the Slovak people is that they're not accustomed to speaking their minds to strangers. They're very reserved, inner people. They'll talk amongst themselves, but that's really it. Also with the meetings, there's going to be a time period when you get there, after you're seated and greeted and seated. They have small talk. They'll talk about the weather. They'll talk about particular holidays that recently happened or are going to come up. Sports, again, like Brazil, we like our soccer. They're also, it's an ice-breaking session to get to know you. They're very, like I said earlier, they're very peaceful people. They crack jokes. Some of them are not funny. I'm just warning you now, some of them will not be funny. Just go along with it. Do appease them. But they're good-natured people. They're non-confrontational with their dealings with others, so they have an indirect way of working their business and dealing with people. So it may seem kind of standoffish, but it's really not. It's just the way that they do things. A couple things to know when scheduling a meeting. You don't want to do it on a Friday, because after lunchtime, they're gone for the weekend, which is usually around 1, 2 o'clock. And in August is the time where most companies shut down for that month and only maintain the skeleton crews. So all the decision makers that would be there for you to do that business deal are not going to be there. With the meeting itself, when you do finally have your meeting, make sure that your presentations are concise, they're accurate, they have all the necessary graphs, tables, all the data that you need to present to make it nice and concise, quick, and so they can observe it, digest it in, and go from there. Also big is when you're doing hands out, you want to have it in their language. Even though some do speak English, a lot of, like I said, a lot of the younger ones do, they like to have the form so they can read it in their language to follow along with you. even if you have a translator or an interpreter there, they like to be able to follow along with what they're doing. Also, they conduct their business slowly. They're not quick, they're not rash rather. They take their time on it. That allows them to just kind of mull it over in their minds and really work through the details in their minds before they go ahead and make a decision or not. Now, with making a decision, it's important to know who's in that meeting, which I talked about earlier. The business decisions is hierarchical, meaning that the owner or the general manager of their company are the ones who make the decisions. So if you have a meeting, and let's say you're working with a sub-manager, or you're working with executives, they're not going to make that decision that day for you. They'll take that information, once they mull it over, they'll bring it to their bosses, to the owner, whomever, go over it with them, and then they'll make the decision and let you know about it. Because that's very, they're very strict on that. There's something, it's ingrained in all aspects of business in Slovakia, whether it be owning a mom and pop shop or owning a big corporation or anything in between, it's all hierarchical. Now, one thing to note here, which I have here, if the GM or the owner is in that meeting, that's better for you. Because if they're in the meeting and you do a presentation, they like what they're seeing and like what they're hearing, they'll make a decision right then. You won't have to wait for them to pass it on and get back to you. Obviously, I was talking about before the charts, the graphs, and everything else that you have. What you'll do is you'll enter a verbal, once everything is settled, you enter a verbal agreement with those people, with the owner or the general manager. Once that gets approved, you go over it and hash out all the details. They bring it to their lawyers. They don't use any outside lawyers, they use their own Slovakian lawyers. They'll draw up all the contracts, all the agreements that are necessary, then you go ahead and sign them, and you're off and you're doing business. Also, the thing they like to do is take you out to dinner or to lunch. With a dinner or lunch is, again, formal. You wear a suit, or you're dressing in a pantsuit for women. Small, you're going to start off in the beginning, they don't talk business. You'll order drinks, you'll order your food, and then your small talk. Sports, obviously, things like that. And then they will bring up business later on when they feel that they're ready. And then you can go on from there. The only difference that between the Slovak and us is the way they eat. Fork is in the left hand, knife is in the right, and they always hold on to them when they're eating. So if you see that, you know, okay, that's how they do things. It's just the way they've always done it. If they offer you a drink, you don't have to drink it. They're semi-big beer drinkers, but if you, for instance, you want a rum and coke, that's what you feel comfortable drinking, go ahead and order it. They won't be offended by that. And these are the resources that I use for the research. Any questions?
Thank you.
We're just gonna finish it. All right, cool. And we're just gonna finish it. The battery.
For my project, I created a third brake light flasher. Who here, including myself, I've had this problem. Who here has been involved in a close call where you're coming to a stop or you're slowing in traffic and somebody behind you almost rear ends you? Yeah, seems like most of us. I have, actually what started me getting to think about this is I have one in my vehicle that I purchased myself. And there's a couple times where I've used it and it kept me from actually getting rear-ended. So what is the third brake light flasher? What it is a module that hooks into your third brake light, which is usually your brightest light, because they're mainly LED. It's a module that functions as an oscillator. and an inverted amplifier. Creates this nice little pulse train, which then outputs to your third brake light, which flashes your third brake light for a certain amount of time and then comes on solid. It could be wired like into yours with your bike here. It can be wired into that, any type of motorcycle or any type of motor vehicle for that matter. How it works: when the driver presses on the brake, the signal gets inputted from the brake light. The brake switch goes out to your brake lights, they illuminate. The oscillator in the inverted amplifier changes the output current. So what it does is it installs two RC time constants, one that will, which are adjustable, will change the amount of flashes and how quickly that they flash. So that, like I said, when you step on the brake, it'll flash a certain amount of times, and as fast or as slow as you want it to. How this is achieved is using a Schmidt-Trigger quad and gate IC. Creates a half monostable, astable oscillator, and then there is the quad NAND gate that's attached to that. Then it also uses the output of a PNP Darlington transistor to output the high to the brake light. This is a normally low state until the brake pedal is pressed. So here we have section 1. Power comes in through R1, which is the trim pot, which is completely adjustable, and then goes through a 47K resistor before it goes into my main on the NAND IC, which is a CD4093BE, which is similar to the 555 timers. It also has, connected to the negative, is a 100K resistor and a 33 microfarad capacitor. When the value of voltage are equal between R4 and C2, this goes, the output of pin 3 goes to 0. So what that does is it allows it to reset itself every single time. So every time you step on that brake, it's going to recycle itself. As you see here, you can adjust R1 between 0.3 ohms to 20.25K ohms. And then you have delay times between 0.01 milliseconds at the 0.3 ohms to 668 milliseconds at the high end of the 20.25K. Section 2 is how fast it pulses. What happens is you have outputs that come in. You'll have the output of 5 loops around here. This will come out and around and run through this resistor, as well as feeding back on the loop between R2 and R7. So what that does is creates the RC time constant. So when the brake pedal is pressed, it goes through section 1, picks up section 2, and allows it to charge C1 and creates the pulse rate that you want. Now, the number of flashes here, when I went through, I measured, so you have certain flashes right now, it's set between 4 and 8, and the resistance values are between the 2.26K all the way down to 8 flashes where it's less than 1.5K. Section 3 and 4 is where everything comes together. This is a Darlington transistor here. This is a pull-up transistor. So what happens is when the voltage comes out and is high, it pulls up to this to output so it flashes. Otherwise it just comes on steady, or if it's not pressed, you don't have any signal coming through it. So designing the McManus 4 module, which I nicknamed it, was done, I created the circuit, the schematic first, which I used OrCAD. One thing was key when building this was making sure that I orientated all the transistors and capacitors right, because when I was building it, I put in one of the transistors wrong and I popped it. nice little magic smoke, as we call it, came out of it, and yeah, that was fun. But this is the basic schematic. So you have R1 there for adjustment, your R2 is over here for adjustment, everything goes through here, and then we'll output, these are your ins and your ground, and then your output here to the brake light itself. Used the PCB editor once that was all set, and then came up with the PC board layout. This I did so it's easier to see where all the components are and all the traces and everything else between the above layer and the top layer and the bottom layer. And these are some photos I did while I was prototyping it. As you'll see here, as the power is on, this LED illuminates when the switch was switched up and flashed and actually worked. This is my completed top and bottom views of my PCB board. And then I have some pictures of final solder, well, semi-soldering, final soldering, and this is it. All soldered, all set to go. And then this is the enclosures I used with the wires coming out on the finalized enclosure. And then for hooking it up, it's easy. 3 wires. This is your in, which is the black wire, hooks to your car battery and the brake pedal. This outputs to your third brake light, and then this is the brake light and ground return. To adjust it, you use R1, which controls the number of flashes, and R2 is how fast they flash. Simply, since it's a trim pot, it's nice and easy. You just use a small micro screwdriver. The one thing which I will get to in a second are the things that change. With that design, when I put in R2, when I did the design work, I put it backwards. So it works, it functions like it's supposed to, but trying to adjust and fine tune everything, I have to kind of bend the capacitor back to get the screwdriver in there. Big no-no, no for next time, flip it around. Also, with the way it is, with this and adjusting it, you have to go by state law. State of Connecticut allows 4 flashes, then it has to go solid. Some states, I know, Massachusetts, they allow 5, and it has to go steady. Some go, say you can only blink twice and then go steady. Unfortunately, the way this is designed, it only goes as low as 4. So in some states it would not be compliant, and that's not a good thing. So I'd have to put an inline series resistor to drop the whole resistance value to adjust it to bring it down to less flashes. And that's part of the presentation. So now to simulate the brake pedal, and your brake light. When you normally step on your brake, your light comes on. It doesn't do anything. You just step on the brake. You can do that. Some people on their cell phone, no big deal. But when I attach this, you attach the brake pedal side to the black wire, and I labeled, and you see real quick, I labeled everything so you can, for easy and for installment, one gets connected to that end. The output of the light goes to the blue wire. And then the return is an extra wire, or you can splice it. Usually you splice it into the wire that's already going back. But for this, we'll do this. Just to the return. Step on the brake. just had this working last night. What's nice about this is I made it easy so you can access everything.
I feel your pain, John. I feel your pain.
Pardon me?
I feel your pain. I was having the same issue.
I just had it working last night before I packed it up.
Circuit's got stage fright, that's all.
Yeah, it could be. Any questions while I'm doing this?
Do you plan on using this in your vehicle?
I have one in there now, and if that goes, yeah.
You have a backup.
So the ones that are on the market now are all micro. They're all surface mount, and they're top and bottom. So they're able to make it. They're able to make them a lot smaller than this. But the design is basically the same. The circuitry, it's just that they're using the smaller tools or the smaller components. Oh,